All right, today we are starting domain and range, but before we dive into that, I do want to recap some of what we talked about on the previous class about functions. So this should look familiar from your homework, but let's evaluate these top 8 together. Starting with 1, I have little f of -2, which means I'm going to input -2 into my little f function everywhere that I have an x, which is just in one place for this one. 2 times -2 gives me -4, minus 3 leaves me with -7, and we're done with that one. Then on 2 we have big G of 3, and in this one I've got 2 places I have to input that -3. -3 squared is +9, 2 times -3 is -6, and then I still have that -7. So 9 minus 6 minus 7, that is going to leave me with -4. All right, then little g of 1, 5 plus 1, which is 6. And then lastly, I've got capital F of -1. -1 squared is +1. 4 minus 1 is 3. Now looking at number 5, little f of -2 plus g of 1. Where have I seen that before? On number 1 and number 3. So I don't have to do that math a second time. I'm just going to add those 2 values and get -1. Then on 6, big G of -3 minus big F of -1. I saw those on 2 and this should have been 4. Oopsie, little typo there. So I'm just going to subtract those 2 values and get -7. Now 7 looks a little more challenging, but again, I already know what all 3 of those values are. I know G of 1 is 6. Big G of -3 is -4, and capital F of -1 is just 3. So when I have minus a negative, remember that becomes plus positive, so I'm going to have 10 over 3 for 7. Then on 8, I am plugging in the expression x minus 2 for my function here. So that's going to be 2 times x minus 2 minus 3. I distribute that 2 to both pieces. So I get 2x minus 4 minus 3. I can combine my constants, and 2x minus 7 is my final answer. So right here you have a worked example of when you're plugging in an expression, you follow the same procedure, but if we're cubing it somewhere, remember that means you have to FOIL. So that's a worked example. I want you to try this one by yourself. So pause the video, try it by yourself, and then come back so we can work it together. So I'm plugging in 2x plus 5 to x squared minus 3x everywhere that I have an x, which is in 2 locations. So that's going to be 2x plus 5 squared minus 3 times 2x plus 5. When I'm squaring a binomial, remember, that's where we have to do our double parentheses so that we remember to FOIL. And so that's going to give me 4x squared plus 10x plus 10x plus 25. Then I can go ahead and distribute that -3 over here. And now I can combine my like terms. So my final answer is going to be 4x squared plus 14x plus 10. And that's just a quick review on functions. Let's move on to our new info, which is domain and range. So domain is our inputs, our x values. And when we're given a function, there are 2 things that determine if we have restrictions on our domain. That would be if an input would cause us to divide by 0, or if it would cause us to take the square root of a negative number. So if your function does not have a variable in the denominator and it does not have a radical, then you have no domain restrictions. And today we're going to be practicing writing these in interval notation, which is where we use parentheses and brackets with our numbers separated by a comma in between. So we use parentheses if we have an open circle, the value's not included, or if we're working with positive or negative infinity. And then we use square brackets if we're looking at a closed circle, the value is included. That's where we use brackets. So let's dive right in, starting here with number 1. 2x minus 5. I do not have a variable in my denominator, and I don't have a radical, so I have no restrictions, and my domain is all real numbers. So from negative infinity to positive infinity, grouped by parentheses, because we always use parentheses with infinity. Then on number 2, Again, I have no variable in my denominator and I don't have a radical, so I have no restrictions. So this domain is also from negative infinity to positive infinity, all real numbers. Now looking here at number 3, I do have a variable in my denominator. So looking up ahead, that was domain restriction number 1. We don't want to divide by 0. So this is restriction type number 1, and now to figure out what my domain can consist of, I have to look and say x minus 5. What input would cause me to divide by 0? Well, that would be if I plugged in 5, right? 5 minus 5 gives me 0 in the denominator, so x cannot be positive 5. So my domain is going to be all values smaller than 5 and bigger than 5, and the way we represent that in interval notation is we say negative infinity to 5, and we use a parentheses on the 5 because remember we're excluding it from our domain. If I input 5, I divide by 0, which is a no-no. So it gets a parentheses, and then I'm going to be going for numbers from 5 to positive infinity. Everything gets parentheses, and I put a union symbol in between them to say it is this set and this set together that represent my domain. That union symbol should look familiar to you from geometry. It looks like a capital U. Number 4, square root of x minus 7. This is restriction type number 2. I don't want to take the square root of a negative number. So looking here, what's inside my radical? I have x minus 7. That value, x minus 7, has to stay greater than or it can be equal to 0. If it's greater than 0, it's a positive number, or if it's equal to 0, I can take the square root of 0 because it is 0. So if I move that 7 over, that means that all of my x values need to be greater than or equal to 7. So how do I represent that in my domain? Well, we always go from smallest to largest, so 7 to positive infinity. Infinity is bigger than 7. 7 gets a bracket because it's included. I can input 7 and get an output. And then infinity gets a parentheses always. Okay. On to 5. This is restriction number 1. Remember, I don't want to divide by 0. And the value that would cause me to divide by 0 here is negative 3, so that should be an x there. X cannot be negative 3. So my domain is going to be from negative infinity to negative 3, and from negative 3 to positive infinity. And we are unioning those two intervals. All right, number 6. This is number 2 again. I don't want to take the square root of a negative number, so that means that 5 minus 2x has to be greater than or equal to 0. If I move that 2x over, that means 5 is greater than or equal to 2x. Divide everything by 2. And so I find that x has to be less than or equal to 5 over 2. In order to satisfy my restriction, which is that I can't take the square root of a negative. So x has to be less than or equal to 5 over 2. So that's going to be all my numbers from negative infinity to 5 over 2. Infinity gets a parentheses, and I get a bracket on the 5 over 2 because if I input that, I will get an output. Number 7, my restriction, I have none because I am not dividing by a variable and I don't have a square root. So negative infinity to positive infinity. Then number 8, I have a radical in the denominator. So this is number 1 and number 2. Now I've already seen the square root of x minus 7 up above on number 4, right? And that domain was from 7 to infinity, including 7. But think about for number 8. If I input 7 into my denominator, I'm going to get 4 over the square root of 0, which is going to cause me to divide by 0, which I cannot have. So to satisfy our additional restriction, our domain is just going to be parentheses 7 to infinity. Okay. All right, and then down here, those graphs did not run, so I'm going to grab that tiny slip of paper, and this is where you can either tape or glue them in so that you have those graphs as well. So go ahead and pause the video to get that taken care of. Great, so now we have our 3 graphs, and we are stating the domain in interval notation still. So starting with A, I've got an open circle here at the negative 9 and a closed circle over here at the 10. Again, we're looking at our x values for domain. So this domain is going to be from negative 9 to positive 10. The negative 9 gets a parentheses because it's an open circle, and the 10 gets a bracket because it's a closed circle. Looking at B, I'm going from negative 10 to positive 10. The negative 10 gets a parentheses, the positive 10 gets the brackets. Again, looking at my open and closed circles there. Then on C, this graph, my x values start at 0 and go off to positive infinity. So that domain is going to be from 0 to positive infinity. Infinity always gets a parentheses, and the 0 gets a bracket because I don't have an open circle here. It's a solid line, which tells me it is included in my graph. Okay, so we've talked about domain, our x values. Now let's move on to range. Range is our outputs, our y values. We still represent it in interval notation with our same rules for parentheses and brackets. So let's look ahead at these three graphs here. My range. I'm looking at my y values. So on number 1, this graph is bouncing back and forth, up and down from negative 3 to positive 3 and all the infinite numbers in between. So my range for that is going to be from negative 3 to positive 3, both with brackets because I don't have any breaks or holes or open circles in my graph. Looking at 2, my graph starts down here at negative 4, that's negative 6, and it's going off to positive infinity. So my range is going to be bracket negative 6 to parentheses infinity because, again, I don't have any breaks or open holes, so I know it includes negative 6, and then infinity always gets parentheses. And then lastly here on graph 3, this graph is going off forever and ever, up and down, so this range is all real numbers, which is negative infinity to positive infinity. Now the last part of these notes, drawing a graph with the given domain and range. There's more than one way that you can do this. So looking on this first set of domain and range restrictions we're given, everything has brackets, which means I'm going to have everything included, closed circles, continuous lines. So I'm just going to mark. My domain is from negative 3 to positive 8, and my range is from negative 6 to positive 10. So one way you could draw this is to do 2 closed circles at those boundary points and connect them with a straight line. You could do a bouncing parabolic kind of graph, or you could even put these 2 boundary points at the opposite corners and do the same thing. Straight line connecting the 2, bouncing parabolically, totally up to you. The second one is a little bit tricky because my domain has parentheses, but my range has brackets, which means I need to make sure that these y values are included while these x values are only included up to that point. So let's go. Negative 2 to positive 11, and then negative 4 to positive 2. One way you could do this would be to do little open circles here, and then make sure you're bouncing up and down to catch those y values. Okay, again, you could also do those in the opposite corners, but a straight line connecting these two is not going to work because you need to make sure that you're including those y values in your graph. Okay, now try to do these another way in your own notes so that you know that there's more than one way to represent the same domain and range. Okay, and that is all for today's notes on domain and range with interval notation. Next time we're going to be talking about inequality and set notation.